explained in the what's that say? Something above.
As explained in the notes above.
Nick has 5 different pairs of socks.
Yep. To last the working week, and they are scattered loose in his drawer.
Okay.
Each morning he gets up before light and chooses 2 socks at random, and then he needs to find the probability that he wears a matching pair on the first morning, on the third morning, and then like.
Okay. Oh, okay. On the first morning, so if he chooses one, so how many socks are there? There's 10 socks altogether, right?
Yeah.
So if he chooses any one sock, right?
Yeah.
Then its matching pair, what's the probability of choosing its matching pair? Well, how many socks will match? Sorry?
1 on 9. So 1 on 90, I think.
Sorry, 1 on 9.
1 on 9, yeah. And then the chance of
Hang on, hold on. No, it's not. Oh, yes, 1 on 9. Good. On the first morning, it's 1 on 9. Got it?
But isn't it 1 on 90 to get?
No.
Okay. So it's
the first sock. Hang on. So the first sock he's going to choose, and will that choice matter?
Oh, no, okay, yeah.
Because it just has to match. It doesn't have to be a blue sock or a red sock. It doesn't, you know. Yeah. All right, so it's just 1 on 9. Okay?
Yeah.
On the last morning, right?
So that would be 5
left
days into it, and that'd be there'd only be 1, or no, there'd only be 2 left, wouldn't there?
Yeah.
So what's the chance of it? How do you find the chance that they're like the same?
Yeah. So this is what you do, Nael. You ready? Yeah. Okay, so you go. So you go. Gotta go. How would you do this? How would you put this in a thingo? So this is choice 1, right? Yeah. And then let's say that they are, let's call these colors A, B, C, D, and E. Got it? And it's A1, B1, C1, D1, E1, right? And then what's this one? What would this one be called? A2, B2, C2, E2, and F2. Got it?
Yeah.
Okay. So your first choice is going to be either, say, A1, right?
Yeah.
And then you got 9 choices, right?
Yeah.
1, A2, A3, A4, A5. Oh, sorry. Hang on, hold on. Let's rub this out.
Couldn't you just do it so that you have 2 branches, but one of them is not A, and then the other one is A, and then write like the chance of it not being A for like the bottom branch, so you don't have to draw.
Yeah. I'm just trying to think. I'm just trying to think of the easiest way, like the most thorough way. I'm doing it the most thorough way, right?
Okay.
Let me just show you. So you can either choose A1, A2, right?
Yeah. Or
B1, B2, C1, C2. Does that make sense? And then D1, D2.
Then A1 and A2.
E1, E2. And they're the choice ones. Got it? Right? Choice 2 would be whatever's. So we've just chosen from 10. Got it?
Yeah.
The next choice would be a choice of choice 2. So it'd be basically A1, A2, B1, B2, etc. Okay?
Yeah.
and then you do the same thing.
And then you'd have to do that 5 times.
Five times, yeah.
Yeah.
I'm just trying to think. Hold on a tick. Let me just have a look. So if you have, so you got 10 choices here, right? Is that right?
Yeah.
10 choices. So you got 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, right? So that's going to be what we call 10 factorial ways of choosing a sock.
Yeah.
So there's 10 factorial ways of choosing a sock. How many ways are there so that on the last morning you're choosing 2 socks that are the same? Okay, so you can either end with A1, A2, or B1, B2, C1, C2, D1, D2, or E1, E2, right? So
Yeah.
and you can either end on A1, A2, or you can also end on A2, A1, or B2, B1, C2, C1, D2, D1, right?
Yeah.
What's that? E to E1. Does that make sense?
Yeah.
How many combinations are there for the way to end on a matching pair?
1, 2, 3, 4, 5, 10.
10. So then this will be 10, and then this will be your 8 remaining socks, right? Which would be 8 factorial.
So for the 2 times 1 at the end would be the final day.
Yes, the final day. That's right.
So then it would be 10 on 8 factorial would be the change.
No. It'd be 8 factorial.
Yeah.
Right? Because that's the way of choosing the first 8 socks.
Yeah.
So that you've got a matching pair at the end.
Yeah.
Got it? And then you times that by 10, because there's 10 combinations of matching pairs you have. Followed, so that's the number of ways that you can end on a matching pair on the last day. Yep.
Yeah.
10 factorial would go on the bottom because that's the number of ways that you can match 10 socks.
Yeah.
Over 5 days. Does that make sense?
Yeah.
So work that out, and I believe your answer would be 1/9. Is it not 1/9?
Yeah. I got 1/9.
And is that the answer? Yeah.
I'll check the answers. I got 10. Yeah, they got 1/9 for B as well.
Mm-hmm. Okay, and then C, I get the feeling again it's going to be 1/9, but I could be wrong.
On the 3rd morning, so that would be
That's my guess. It's going to be 1/9, but until I work it out, I don't know. Can you check the answers in the back?
so for this one, would you do it the same way as the last one by
Yep.
so it'll be 10. It will still be 10 factorial on the bottom, won't it? Because there's still 10 different combinations.
Yep.
For each
Yes.
thingo. Then it'll be what's above it will change. So It'll be rather than. So we'll have to cancel out everything after. So 1, 2, 3.
So what I would do is I would work out the number of combinations in the third morning first. Okay, so this is the first. This is day 1, right?
Yeah.
Day 2, day 3. Okay, day 4.
So there's 10 on the first day, and then wait, no.
No.
On the
On the
first day
third day,
there's 10, and then on the second day there's 9.
Yep.
So I mean like 10 factorial on the first day.
Yep.
And then 9 factorial. No.
No. It's this.
Factorial.
Yeah. So what I would do is I would work out what I'm going to choose on the third day first, right? So on the third day,
It would be 6 factorial.
no, it won't be 6 factorial. You can
Why not?
lock it. We're going to lock in the number of the different combinations of socks that are going to be successful on the first day, right? On the third day, all right? So we can either choose A1, A2 again, right? Or
Yeah.
A2, A1, right?
Mm-hmm.
B1, B2, or B2, B1. Does that make sense? Do you see what I'm doing? Right? So how many combinations can we choose on the third day that are going to be successful? 10, right?
Will it be 10 again, or will it be less than 10 because 4 have already been removed from the...
It'll still be 10, right? Because we're locking in the combinations that will satisfy our criteria first.
Yeah.
And then we're going to work everything else around our criteria.
Yeah.
Okay, so the answer is there are 10 ways of getting a matching pair on the third day. Okay?
Yeah.
Makes sense?
Mm-hmm.
All right, because it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Does that make sense?
Yeah.
Yep. And then how many socks can you choose here?
So for the first day?
Yep. 10.
10.
Yeah. How many socks can you choose here?
9.
9. How many socks
8.
can you? 8.
And then 7.
7. And then there's 10 ways of choosing the right socks that we want.
Yeah.
Oh no, sorry, it won't be. Sorry. Hang on, hold on. Let me just rub this out. Okay. Sorry, this will be 8, right? 8, 7, 6, 5. Because we're choosing these two socks first. Or it's not choosing those two socks. We're locking in those 2 socks first.
So what happens to the 9th then? Because the 10th is already...
Okay, so if we already set the criteria, right?
Yeah.
That the first, the third, and the fourth socks. Oh, sorry, the socks that we chose on day 3.
Yeah.
Are going to be locked in first, right?
Mm-hmm.
Then how many socks are left to choose on day 1 and day 2?
I'm kind of confused.
Okay.
Because...
Well, let me just share what I mean. Okay, so forget the order that we're going to choose the socks, right? What I want you to consider is the order that we're going to analyze our combinations, right?
Yeah.
Now, we just need to make sure that we choose a matching pair of socks on day 3. Okay.
Yeah.
So we've got to lock in that matching pair on day 3 first.
Yeah.
Okay. And then we arrange the rest of the remaining socks around meeting the criteria. Okay.
Yeah.
So we already know that the total number of combinations of choosing or the total number of arrangements for choosing 2 socks that are exactly this. So the total number of ways of choosing 10 socks into 5 pairs over 5 days is 10 factorial. Does that make sense? We already know that.
Yeah.
But the number of socks that will meet this criteria, right?
Yeah.
Got to meet the criteria first. Okay.
Mm-hmm.
So there are of the 10 socks where we choose 2 that are going to match, right? There are 10 ways of doing that on day 3. Does that make sense?
Mm-hmm.
So we lock in that combination first, right?
Yeah.
And then now we already know that this criteria has been met, okay? But then what we've got to work out is how many ways are there of meeting this criteria,
Yeah.
okay? And that is we've got to arrange the remaining 8 socks around meeting this criteria, okay?
Yeah.
8 socks left, and you've got 8
But
positions.
it wouldn't be 8 socks remaining. It would be 6 because it's on the third morning.
That's right. But
Yeah.
of the ways that we can meet this criteria, any 10 of the socks, right?
Could
10 of the socks can meet that criteria.
Yeah.
Right? And it doesn't matter that there's 6 socks left by the time we choose this here, right? Because when we start off, any 10 of the socks can fit into this here, depending on which socks we choose up front. Okay?
Yeah.
So, but we're not going to we're not going to worry about which socks we choose up front. We're more interested in prioritizing the socks that meet the criteria up front.
Yeah.
On day 3. Okay. So we lock in the 10 ways that we can meet that criteria on day 10, which means that we've got 8 socks remaining. Okay.
Yeah.
Okay. And those 8 socks can be arranged in those 8 positions: 8, 7, 6, 5, 4, 3, 2, 1. Does that make sense?
Yeah.
So if we only consider that, then it's still 8 factorial times 10.
So times 10. So it'd be the same every day, like for picking
Yes.
2. Yeah.
Yes. And is that right?
Yeah.
Is that the right answer in the back of the book?
Yeah.
Yeah. Yeah. Does that make sense?
Yeah.
You sure?
Yeah. So the starting, like, first 2 picks don't affect like the third morning pick.
No, they do. They do when you do them in this order. Okay? But when you're counting the arrangements, when you're counting all the possible arrangements, right?
Yeah.
We're trying to eliminate the ones that don't fit that. Okay?
Yeah.
Hold and only count the ones that do fit a matching pair for day 3. Okay?
Yeah.
So when we actually calculate the number of ways, we lock in the criteria first, right? And then we can work out where the other socks fit in around it. Does that make sense?
Yeah. Because we haven't like done this in like the chapter earlier, so
Yeah. Well, don't worry about it too much. Right?
Yeah. Okay.
Cool. And then let's have a look at what is it, part D. The first 2 mornings, is that right?
Yeah.
Okay. Have you done that one?
No. So on the first two mornings, wouldn't it just be 1 on 81? Because there's 1 on 9 for the first morning and then 1 on 9 for the second morning.
No. Let me show you how we do this. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 10. Okay. So we want matching pairs for the first two mornings, right? So what would the matching pair be for the first morning? Or how many ways can you match pairs for the first morning? We worked out 10, right?
Yeah.
Does that make sense?
Mhm.
We have A1, A2, B1, B2. Oh, sorry, hang on.
And then
A1, A2, or you can choose A2, A1, B1, B2, B2, B1, etc., all the way
Yeah.
up until E1, E2, E2, E1, right? And that gives us 10, 10 combinations. Does that make sense?
Yeah.
That's 10, right? Now, after we choose those 10, right? How many cards are left over?
So there'll be 9. Oh no, there'll be 8 left over.
8 left over. How many ways can you choose a matching pair from 8 remaining cards?
8.
Yeah, so you can choose A1, A2, B1, B2, C1, C2, D1, D2, right? There's
Yeah.
8. Okay. All right. So there's 8 ways of choosing this one, right? And then how many cards are left over?
After that or during?
Yep. No,
After there's 6.
6. So then those 6 cards, it really doesn't matter how we arrange them.
Yeah.
Okay. So then we've got 6, 5, 4, 3, 2, 1. Got it?
Mm-hmm.
So the answer for this question would be, right, 10 times 8 times 6 factorial over 10 factorial.
So 10 times 8 times 6 factorial, which gives you 1 on 63.
Yeah.
So for the first day, you have 10, and then for the second, yeah, that makes sense. Okay.
Okay.
Yeah.
Okay. Now, you want to try part E?
So every morning. So it'll
Every
be
morning. So let me just rub this out, and you tell me how we do
yeah. So it'll be 10 for the first day, and then 8 for the second day, and then 6 for the third day, and then 4 for the fourth day, and then 2 for the last day.
Yep.
So you do 10 times 8 times 6 times 4 times 2 on 10 factorial, which is 1 on 945.
Sorry?
It's 1 on 945.
Yep. 1 on
945.
945. Good. Okay.
Yeah.
All right. Now this last one's actually quite a tricky one. And it's saying we want every morning to have a matching pair, but one.
Yeah.
Okay. Do you know what the answer is?
So every morning but one.
Yeah, without looking at the answers.
I'm not really sure.
I'll tell you what it is, and you tell me what you think about it.
Oh yeah, because you can't. Oh yeah. Because if you have matching pairs for every day, then the last one has to be a matching pair.
Yes, that's right. You can't not have it be.
Yeah. That makes sense.
Good. Got it?
Yeah.